Time, it rules our life. Every second, every heartbeat, every sunrise and every sunset. It flows like a river, steady, unstoppable, taking us from cradle to the grave. But here is a question: what is time? And more intriguingly, can we break free from the grip of time? Today's Bite Size is inspired by Colin Stuart's fascinating book, Time, 10 Things You Should Know. We'll journey through the mysteries of time, why times always flow forward, how gravity bends the time, and what does black holes do to the time, and of course, is time travel a science fiction or a science fact? So buckle up, we are about to bend your mind. Watch the video till the end. If you are seeking clarity in the core concepts, fundamental principles and basic beliefs of all religions, history and philosophy, you have come to the right place. Welcome to my channel, History, Religion and Philosophy Bite Size. Please don't forget to subscribe, like and share. What actually is time? Philosophers struggled with this mystery long before science had the tools to measure it. In other words, for thousands of years, time was treated as a concept, slippery, elusive, almost like a philosophical poetry. Then came science with Galileo, Newton, and finally Einstein. Time stopped being just a riddle for thinkers and became a measurable, bendable dimension of reality itself. And that brings us to today's big question: is time travel possible? We think of time as a clock ticking or the numbers on our phone screen. But for physicists, time isn't separate from space. It's part of a four-dimensional fabric called space-time. Einstein proved this over a century ago. Motion and gravity both affect how time flows. To someone flowing at near the speed of light, time slows compared to you and me. This means time isn't universal, it's personal. Your watch and my watch might tick differently depending on where we are and how fast we are moving. That's the first clue that time travel might not be so far-fetched. Yet time feels one way. You remember yesterday, not tomorrow. Eggs break, but they don't unbreak. Why? This is the arrow of time, and it's connected to entropy, the measure of disorder. The second law of thermodynamics says disorder, entropy, always increases. That's why the universe is expanding, stars are burning out, and why our lives move forward. Without entropy, time could, in theory, move backwards. But because disorder always grows, we are swept forward like being on a conveyor belt that only goes one way. The purpose of the bite-sized videos is to break down complex concepts into simple and easy to understand narrations. It requires a lot of effort and research. Please don't forget to like, subscribe and share so we can spread the message as much as possible. Einstein also showed that gravity doesn't just pull, it bends time. The stronger the gravity, the slower time flows. This isn't just science fiction, it's been measured. Put one atomic clock on a mountain and one at sea level and they'll tick at slightly different rates. Astronauts orbiting Earth come home younger by fractions of a second compared to us. Now scale that up. Near a black hole where gravity is extreme, time slows down dramatically. Here's a mind-blowing example. Spend just 1 hour near a black hole and when you return, you could find that 7 years have passed for everyone else far away. This is relativity in action, and it shows us that black holes are natural time machines propelling us into the future. Let's pause here. We have established that moving into the future is possible. Here is the key. The closer you travel to the speed of light, the slower time flows for you compared to people left behind. This is called time dilation. Imagine this: you board a spaceship that can travel at 99.9% of the speed of light. You fly for 5 years according to your onboard clock. When you return to Earth, how much time has passed here? Not 5 years, not even 10. It would be about 100 years. So while you have only aged 5 years, an entire century has gone by on Earth. You would come back to a future where all your family and friends are gone. Entire generations have passed and the world may be unrecognizable. This isn't just speculation, it's built directly on Einstein's equations. Astronauts in orbit already experience a tiny version of this, aging microseconds slower than us. But at near light speeds, the effect becomes dramatic. In other words, a spaceship moving close to light speed is a real one-way time machine to the future. Let's talk about time travel to the past and paradoxes. Going backward in time introduces some of the most famous paradoxes in physics. First, the grandfather paradox. If you travel back and prevent your grandparents from meeting, you won't exist to make the journey. So which version is true? Then there is the bootstrap paradox. Imagine traveling back and giving Shakespeare a copy of Hamlet. He publishes it, and centuries later you read it and take it back to him. Who wrote the play, Shakespeare or you? Physicists wrestle with these questions. One possible solution is the Novikov self-consistency principle. It says that events in space-time are fixed. You can go back, but you cannot change anything that would create a paradox. In other words, history is self-consistent. Another solution is even wilder, the many-world interpretation. Each change creates a new timeline. Kill your grandfather in one and you simply branch off into an alternate universe where you're never born, while the original timeline continues untouched. So past travel might be possible, but not in the way we imagined. How would you actually time travel back? Physics offer a few exotic possibilities. The first is wormholes. These are like tunnels connecting two distant points in space. If one end of a wormhole were moved near light speed, time at that end would slow down compared to the other. That desynchronization means stepping through could take you not just across space but back in time. Cosmic strings are hypothetical one-dimensional defects in space-time left over from early universe. Two of them moving past each other at near speed light could bend space-time enough to form a closed time loop. And then there is the closed time-like curves predicted by Einstein's equations, paths through space-time that circle back on themselves, essentially allowing an object to return to its own past. These ideas are mathematically possible but practically impossible with today's technology. Wormholes may require negative energy or exotic matter to stay open. And cosmic strings, if they exist, have never been found. Still, the maths leave the door open. Some of the greatest minds have weighed in. Stephen Hawking believed that there might be a chronology protection conjecture, laws of physics that prevent past time travel to protect the universe from paradoxes. Kip Thorne, who worked on the movie Interstellar, showed that wormholes might allow backward travel, but exotic matter required may not exist. And all of them agreed, without faster than light travel or near light effects, we are locked into slow journeys forward. The speed of light is the universe's ultimate speed limit, and it's also the gateway to any realistic form of time travel. So is time travel possible? To the future? Absolutely, and it's happening already. Travel close to the speed of light or near a black hole and you will leap ahead in time. To the past, the door is cracked open, but we don't know yet if we can step through. Wormholes, cosmic strings, quantum loops, they all remain tantalizing theories. Colin Stuart reminds us, time is our prison, but also our playground. Understanding it pushes the limits of science, philosophy, and imagination. And maybe the greatest time machine we already possess is the human mind, carrying us endlessly backward in memory and forward in imagination. Time travel, in a way, is already happening. What do you think? Will humanity one day build a time machine, or is the past forever out of reach? Tell me in the comments below. If you have enjoyed this journey, hit like, subscribe and ring the bell, because the future of this channel depends on you.